Okay guys, here's another graph question of the Doppler effect. Let's cut the chase. A police car moving at constant velocity with a siren on passing a stationary listener. The listener is stationary, so the velocity of the listener is 0. Now it says the graph below shows the changes of frequency of the sound of the siren detected by the listener. So this graph, guys, this is a graph of the frequency of the listener versus time. So we know the line that is top, it means that it's towards. It was towards, and then the one that it has a lower frequency, that means it's what? It's away. So the police car, it was moving towards, and the observed frequency, it was 170, and what it was moving away, the observed frequency, it was 130. Now 6.1, it says state the Doppler effect in words. Guys, stick to exam guideline. I'm not going to state that. Okay, write down the frequency of the sound detected by the listener as the police car approaches. As the police car approaches, which is towards, so the frequency detected by the listener is 170 hertz, right? And then while it moves away, it's 130 hertz, right? The last question, it says calculate the speed of the police car. Take the speed of the sound is 340. Guys, we're not given the speed of the velocity of the source, the frequency of the source, and the velocity of the source. We are not given there. So we have two unknowns here. In 6.3, guys, we do not have the frequency of the source and we do not have the velocity of the source. So we have two unknowns, and then we're given the two frequencies, the away and towards of the listener. So I will use the simultaneous equation. I'll start with towards. Let me start with towards. Right, we know towards it's plus and minus at the bottom. So I'll create equation for towards. So say frequency of the listener is equal to V plus VL, V minus Vs times frequency of the source. Now I substitute. What is the frequency while it was moving towards? It's 170. We got it from the graph. 170, and the speed of the sound in the air is 340, we're told there, plus the velocity of the listener. The listener was at rest, it was stationary, so it's 0 divided by 340 and minus the velocity of the source we do not have, and the frequency of the source we do not have there. So we're going to have 170 340 times Fs divided by 340 minus Vs, right? And then we cross multiply. This times that. So it will be 340 times Fs equal to 170, open bracket, 340 minus Fs. I'll take that as equation 1. And then I'll create the equation 2 for away now. Right, we know away it's minus divided by plus, and then it's FL is equal to V minus VL divided by V plus Vs times frequency. And then we substitute. What was the frequency while it was moving away? It was 130 there in the graph. 130, and then the speed of the sound is 340 minus the velocity of the listener is 0. Plus the velocity of the source we do not know, times by the frequency of the source we do not know. So since it's 0 there, so it will be 340 Fs divided by 340 plus Vs, and then 130 there, and then we cross multiply, guys, just like we did in the previous equation. And then when we cross multiply there, and we have 1 there, we cross multiply. So we're going to have 340 Fs is equal to 130, 340 plus Vs, right? And then we have equation 2. So we're going to substitute the 2 equation. Do you see we have 340 Fs is equal to that, and here we have 340 Fs is equal to that. So we'll just equate the two things. So we'll say 340, there's no need for this, but I'll do it. 340 equal to 340 Fs, and then I'll take this one, it's 130, open bracket, 340 plus Vs equal to, take the top one, it's 170, 340 minus Vs, right? So you can see now we have one unknown, which is Vs, right? So we have to distribute this times this, and then this times that. So in my calculator, quickly, it's 130 times 340, it's 44,200 plus 130 Vs equal to this times that, 170 times 340, it's 57,800, and then times 170 times Vs, it's 170 Vs, and then we cross multiply. No, we group. We're going to group. We take this to this side and we take this to this side. So it's going to be 130 plus 170. It's going to be 300. So it's going to be 300 Vs, and then the 44,200. No. So we're going to have 57,800 minus 44,200. So 57,800 minus 44,200. So the answer here is 13,600. So we have 300 Vs, and then we divide by 300. We divide by 300 both sides, and then your Vs. So we divide the answer by 300. No ways. So it's 13,600 to divide by 300. So the answer here is 45,3 meters per second. That's the speed. That's the speed of the source, right? I hope, guys, this makes sense. We were calculating the speed of the police car, right? It's 300 and it's 45,3, guys. Thank you. Bye.